Welcome everyone to our next session with Shelby. Shelby leads an AI research team at Salesforce, where her team focuses on applied and fundamental research in emerging directions of AI, including autonomous agents, on-device AI, LLMs, and beyond. Welcome, Shelby.
Awesome. Thank you so much for the intro. So I'm super excited to be here today. This is actually my second Girl Geek event. So I gave a talk at a Girl Geek event 2 years ago. And back then I was speaking on recommendation systems because at the time there was a lot of innovative recommendation system work going on. But if we think about what's happened over the past 2 years, the AI world has changed, right? I mean, the whole tech industry has changed, but AI has really just so much innovation at unprecedented pace, right? So the biggest question I usually get asked nowadays is what's next in AI? What's after LLMs? And how can I stay ahead of the game? How can I get ready for it? So that is what this talk is about today. Today, I want to tell you about what's coming in GenAI. And one of the key directions is what we call LLM-powered agents. So that is what we're talking about today. So why am I talking about this topic? Well, as you heard in my intro, I lead an AI research team. So our team's mission is to focus on the next frontiers of AI. So my team focuses on thinking ahead on what's next. And so as part of our mission, we're constantly defining and innovating at the frontier. So we publish tons of research papers and conferences and workshops. We also have a ton of open source repos. So we make our work publicly available. I'll talk about one of our open source repos today to help you get started. And all of this is so that we can ultimately ship cutting edge AI to customers. That's ultimately our goal here at Salesforce, right? So that's a little bit about me, my personal background. I entered the AI world with a PhD in machine learning, and I really come from a math background. So I've been technical, been in this space for quite some time. And I'd love to connect with you all. Feel free to scan the QR code to read a little bit about my background, but also we can connect on LinkedIn. I'd love to meet people from the Girl Geek community. So I want to give you a little bit of background about Salesforce too. So as we know, Salesforce is this great sales and marketing software, and Salesforce has been innovating in AI for the past 10 years. Yes, 10 years. So it's kind of crazy. So they founded the AI research team back in 2014. That was before I was joining Salesforce, but the AI research team at Salesforce has been around for quite some time, 10 years, and has been innovating ever since. Okay. And so the numbers are just massive. So if you look here on the right, we can see the past 10 years, Salesforce has generated over 300 AI patents, over 227 AI research papers. So my team contributes to those numbers, but there's just so much that's been generated in the 10 years. And it's not just about generating AI in isolation. At Salesforce, we prioritize trust. Trust is our number one priority. So we build trusted and ethical AI. So we're a part of 6 ethical AI councils. And most recently, we've been heavily involved in the White House commitment for trusted AI. So it's not just AI innovation, it's trusted AI innovation that we build. Now, I want to draw your attention to what's been happening, as we said, the past 2 years. Let's look at 2022, 2023. As we can see what's happening, even at Salesforce, what we see is LLMs. You see LLMs we're deploying. We've got Einstein GPT we deployed. We've got Tableau GPT, Sales GPT. The point is lots of LLM products being deployed. Now, let's zoom out. It's not just about Salesforce. We're talking about tech industry, general trends. Lots of companies, lots of places are deploying these LLM products, and they're fantastic. So as we know across the tech industry, we are seeing LLMs being used for document generation, for content editing, for question and answering, search, summarization, translation. So LLMs are, as we know, just a powerhouse. They're solving so many problems and able to bring so much value to customers. So today, though, the goal is to tell you what's after these use cases. There's more. These are just the beginning of what we can do with LLMs. And in order to understand what's next, I want to make sure we all come together and have some general intuition on how LLMs work. So what are language models? Let's forget the large part for now. Let's just think about language models. So language models are what we call next word predictors. As you know, in machine learning, we train models on data so that they can predict. Language models are a special case of that, where we're training a model so that it can predict the next word given some sequence of previous words. So this picture depicts exactly that. That is what we call a language model. And typically tons of data is consumed by these models for training. And so even though these models, they're trained on this next word prediction task, so they're really good at next word prediction, that sounds simple, but a lot of skills come implicitly when you train on next word prediction. So let me give you an example here. If we look at this table on the right, I won't go into every detail here, but let's just look at the first item. If we are training our model on this task, in my free time, I like to blank. As you can imagine, if we had a lot of sentences like that, in order for the model to be good at predicting the next word, it implicitly would have to start to understand grammar. It starts to learn grammar along the way. And so there's a lot of other tasks that come along with this next word prediction. So lexical semantics, the language model starts to learn world knowledge, of course, if it sees enough sentences like the capital of Denmark is Copenhagen, for example. Sentiment analysis, translation, math. So language models can learn a lot from this very simple task of next word predictions. Now, large language models. We talked about language models. Where does the large part come in and what value does that bring? So large language models are language models, but they're huge. By huge, we mean they have a huge number of parameters. So number of parameters, we mean weights in the deep neural network. So ultimately, these are, language models are transformer-based, deep neural networks, and to make them a large language model, they have a ton of these weights. So I'll get to that in a second. And they're also trained on massive, massive data sets. So let me illustrate that. So let's go ahead and look at this table here on the right so we can see the progression. So this table is a little bit outdated, but it still proves the point that I'm trying to make. So if we look back in 2018, BERT was considered one of the first LLMs, the first large language models to emerge back in 2018. It had 109 million parameters, or 109 million weights in its deep neural network. Now, fast forward to 2022, we look at the Palm model, 540 billions weights in its deep neural network. So size of these large language models is massive. Now, also look at how much training data, how that's different. In 2018, BERT trained on 250 billion tokens. For today, you can think of tokens as chunks of words. They're not necessarily full words, but think of it as like a token is like a chunk of a word. 250 billion tokens today, or not today, 2022, today would be even more, 780 billion, so more than 3 times the amount of data. So bigger model, more data, but why? Why do they need to be this big? Why did we do this? Why? So of course, first reason, these models are going to be bigger models, bigger capacity. They're going to be even better at these tasks. They're going to be even better at grammar, lexical semantics, world knowledge, and so on. So bigger model just has more capacity to learn. They're going to just perform even better. But here is one of the key magic pieces about it. As LLMs scale, as the number of parameters increases and the data set increases, new abilities emerge. So there are more skills that we would add to this list that only happen because the LLM was sufficiently large enough. And 2 of those skills that are really important are instruction following. So that's why for LLMs today, we can pass it a prompt and give it instructions. We can say to an LLM, hey, here is my task, complete this task, and the LLM follows that instruction, because that comes with the scale of the LLM. It has to be a sufficiently large LLM for it to do that. Then the second really important ability is learning from examples. So this is why if you've had experience playing with LLMs, you can not only pass instructions, you can also give it examples. So maybe it's instructions it's never seen related to training data it's never seen. You can actually pass in examples of how to actually execute on those instructions, and the LLM can learn just from those 2 examples how to create the correct output. So this is really where the amazing features of LLMs comes through. So it's the fact that at this scale, these new abilities emerge. And so now that we have hopefully some intuition on the value of LLMs, and how LLMs work, let's start thinking about the core of today's talk, which is LLM-powered agents. So it's built on LLMs based on the name, but I want to tell you about what an LLM-powered agent is now. So what we see here on the left is a standard LLM task. This is kind of what we've talked about in the past 5 minutes. If we look here, Astro, our Salesforce character, is saying, write a short response to this specific email. We know that LLMs can achieve, tasks along this line. We've seen products being emerged all across the tech industry doing things just like this. That's a lot of value. But today we're talking about the future. We're looking beyond what can be achieved today. And what we want to do in the future is enable even more complex tasks to be solved. So now let's take a look at the right. The right here, we see Einstein saying, write and send email invitations to my friends about my birthday party. So this is significantly more complex than what we see here on the left. So let me break down why. First, we're saying Einstein is asking to write and send multiple emails, right? So there's more work to be done here. There's more emails to be written. Okay, so more work. But that's not the only reason it's more complex. Einstein is also saying send those emails. So remember, on the left, it was just writing a specific email. Now Einstein is saying send those emails. He's asking for an action to be taken. So that might require calling an email API, or that might require navigating an email app. So that is something that is some work that needs to be done. Now, not only we're writing emails to our friends, right? To our friends. So how would we figure that out? That is a complex task as well. We would need to maybe that will require, investigating our social media or our emails to figure out who those friends are. And finally, there's a birthday party here. How do we find information there? That might be an email. That could be, again, on social media. The point here is that this complex task can be broken down into finding out who my friends are, writing emails, sending emails. And so here's the key for today. Each of those steps, finding out the friends, writing the emails, sending the email. Guess what? The LLM can do each one of those steps. So this is an LLM task. This is an LLM task. This is an LLM task. So the idea is that we're going to apply the LLM over and over again. And then there's one other critical piece of information. That initial breakdown where I took this task and I broke it down into finding the friends, writing the emails, sending the emails. That plan, the LLM can do that too. So this system, a system that continually calls on an LLM for planning and for execution of that plan, is what we call an LLM-powered agent. So this is what an LLM-powered agent is, everyone. So here's a breakdown of how an LLM-powered agent system looks like. So the agent itself interfaces with the user. So in this case, the user is saying, write and send pitch emails to my top 5 leads in Q2. Great. So that is information that's being sent to the agent. Now the agent is the one directly communicating with the LLM, writing the prompts so that the LLM can create the plan. So the agent may take that request from the user and say, hey, LLM, break this down into some reasonable steps. The LLM will output the steps. Then given those steps, the agent continues to call the LLM to complete those steps. Now, LLMs alone aren't enough. So an important part of an LLM-powered agent system here are the tools in memory. So let me break that down for you. So LLMs aren't enough. First of all, we know LLMs have knowledge gaps, and that's just by the way they're built. So LLMs are pre-trained on lots of data, but it's a finite amount of data. It's not pre-trained probably on today's world events, or even domain-specific data. They're just typically not trained on that type of data. And so having access to APIs, apps, software, functions, being able to access those can help fill those knowledge gaps. So what an LLM-powered agent can do is use the LLM to generate the appropriate API call, or use the LLM to generate the right database query even to retrieve the relevant data. So here's an example. If we look below, we could see this prompt. Maybe the agent sends to the LLM, hey, tell me the API for determining what's the weather today in Sunnyvale. So we know for a fact the LLM is not going to just inherently know that. So the LLM, instead of hallucinating or instead of making something up, we instruct it, give me the API call. The LLM will output the correct API call, which may look something like Google Search API with the right API parameter. So the other problem, so that's one gap that's filled by, allowing, integrating tools into the LLM-powered agent. Now, the second gap that's filled is around the skill gaps that LLMs have. So as we know, LLMs are built, they produce text, right? So we may need LLMs to take action though. So remember that email send example? We may need the LLM to actually take action, to actually send in an email. So again, we can send the right prompt so that the LLM sends the right API call or the right UI action. Maybe it's navigating a user interface. So here's an example below. Maybe we say, maybe we send to the LLM, send a Slack message about the weather. The LLM can respond with the right API call to actually send that Slack message. So that's the value, and that's the value of tools. So finally, I want to talk about memory. So what is memory? Why do LLM agents need memory? So one of the key limitations of LLMs is that they have a limited context window size. Long story short, you can only pass so much information into the prompt. The prompt can only handle so much text. But as an LLM agent is working and executing, right? LLM agents are maybe working on multiple steps to achieve a complex task. Information captured along the way could be really helpful context. So for example, maybe the LLM agent is, talking to the user, getting feedback from the user, asking follow-up questions. That's all valuable. And also the LLM is working with, maybe calling APIs, calling apps, calling tools. The outputs from that, maybe, call the Google Search API. The output from that, very valuable and may save time down the road, so we don't have to call that API again. All these things would be great to be saved. So this is where external memory comes in. So in an LLM agent system, you want to make sure you have some sort of mechanism for external memory, so that this conversation history and progress along the way can be saved, so it can be referred to later on. So practically speaking, the external memory, one of the most common ways, and there's lots of ways to implement this. One of the most common ways though is with a vector database. So the idea is that text that you save along the way, whether it's conversation history or outputs from APIs, outputs from apps, it's converted into embedding vectors stored in a vector database, and then when it needs to be, then it can be retrieved with embedding search along the way. So that's how at a very high level, that's how memory works. So I just gave a brief overview of LLM-powered agents. I hope everyone understands conceptually what they are. So if you're ready to build your own, actually get your hands dirty with building LLM agents, I wanted to introduce our open source repo called Agent Lite. So feel free to check it out by checking the QR code. It's lightweight. The point of, we built this so that it would be very, very user friendly. As you can see, in terms of like lines of code and what our library contains, very few lines of code. It's really lean implementation, yet we have the key components needed for agents. So you can build custom agents. You can decide the actions the agents can take, the APIs it has access to. You can, if you want to get fancy, you can build multiple agents and they can talk to each other and work together to solve complex tasks. And we have tutorials for you to get started. So here's a quick illustration just showing in 4 lines of code how easy it is to get started here. So again, to build a custom agent, you need to specify an LLM. You need to specify which APIs or actions it can take. And as we just talked about, there's memory here too. And so in just 4 lines of code, you can build a quick agent. And with that, I hope you guys took away from this. I hope you guys understand now what an LLM-powered agent is. I hope you guys can see that it really is the next natural step from LLMs. There are already, LLM agents products emerging, but stay tuned. There will definitely be much more emerging in the tech industry. If you found this interesting, check out our research, talks, and blogs. And also, if you're interested in that open source repo that my team built, Agent Lite, you can scan that QR code. Thank you so much.
Thank you so much, Shelby. This was absolutely wonderful. I hope you'll stay for the remaining sessions of the day. We're going to move on to our next session. Thank you.
Awesome. Thank you. Take care.